No? All right. I will start with 11 and 12 then. For something like question 11, anyone have a good idea of where to get started on that one? Left or right side?
Left.
Left side. And is there anything within that that is kind of familiar to us?
Squares, right?
Yes, it's a difference of squares. Good. So if I factor that as a difference of squares, it would be sine squared plus cosine squared for one parentheses, and sine squared minus cosine squared for another, right? Since it's to the fourth power, that would just make those both squared. Then we hopefully should start to be recognizing this kind of thing right here. What is that the same as?
1, right?
Yes. So if that's 1, that's essentially just 1 times sine squared minus cosine squared, which is just our right-hand side. Okay. Does that one make sense? Okay, and then for 12, it should kind of be obvious as to which one is a little bit more complicated than the others. So we should be starting on the left-hand side here. What can we do with both of these parentheses?
You can factor them out.
Maybe you want to FOIL those out, right?
Or FOIL
So
them.
make sure that's not just squaring both terms. You want to make sure you're fully foiling. So the first one would become sine squared. If I did the outer terms and the inner terms together, that would be sine times cosine, so 2 sine times cosine. And then plus cosine squared. And that's all just from this first one. Then I would do the same thing with the second one. So sine times sine is sine squared. Outer and inner, this time because of the minus, gives me minus 2 sine times cosine. And then the last terms would turn into cosine squared. What is going to happen nicely here for us? I got this one and this one. What's going to happen with this?
Cancel out, right?
They're going to cancel out, right? So then from there, I have sine squared plus cosine squared, which we just said in the last one is 1. We have another sine squared plus cosine squared, which is also 1. 1 plus 1 gives us.
I didn't know to film our girl next night properties tomorrow night to have a little more prepared for it. Hello, are you okay? Are you okay? The girls are tag teaming later this.
Someone's not muted there. All right.
Now, we'll be back.
All right, so there is that.
Okay, I just put this on in case I have to start on. Oh. Okay, well, it's time for me to tackle this. This has gone way overboard.
Susie, mute yourself.
That's,
there we go.
I muted her, but
Okay.
all right. Any other homework questions we're not sure about from that same one? Or we're all good? Okay. I uploaded, if you want to pull it up on Canvas, you can. But I uploaded another little practice page on double angle identities. So that's what I'm going to be working on today. This, unfortunately, is the unit where I usually end up like printing an extra thing and handing it to you. But you can follow along and write these down. Or if you have a chance to print it real quick and use that, you're welcome to do that. But that's kind of going to be what I'm working with. So we're really spending today and the last class doing the double angle identities, a little bit more practice with that. Next class, we will talk the last identities that we need to know, which is the sum and difference. So that's going to be next Tuesday. Is the 9 a.m. time okay for people, or? I don't know. I'm just kind of randomly throwing out times, honestly. So
That's good.
that's good. All right. Hopefully I'm not interrupting with anything else that's going on. So I'm just going to go through a couple of these double angle identities with you to get you a little bit more comfortable with those. And then we will see what questions we have from there.
Those are not on the quiz.
Those are not on the quiz. No, this quiz is very much just the first, the reciprocals, the Pythagoreans, and that is it.
Okay.
So you need to know, part of the quiz is filling in the identities for yourself. So it's basically, I took the identity sheet and just made little blocks for you, so that you could just fill in where they are, and then use that on the rest of your quiz. Same format as the last one. This whole unit in particular does not lend itself to multiple choice questions whatsoever. So I'm not trying it. We're just going to try to do our best with writing down our work and uploading it. Do be aware that because this quiz for A-Day is on a Friday and it's not till Monday, you're not, for B-Day, you're not going to get any feedback until after everyone's turned it in for B-Day, just because people can share stuff. So
And it can be done anytime today, right?
yes, anytime today for second period. Yep.
Okay.
All right. So a couple of these double angle identity ones. I'm going to just start with going through question 10. Sometimes on these, and the reason I want to go through more of them is sometimes it's best to get rid of the double angle one first, and sometimes it's not. It kind of depends on the question and how you want to look at it. So in particular, let's talk about question 10 right now. If anyone can answer, what side would you start with on this one, on question 10, if you were looking here?
Left, probably.
I would start with the left myself. And the left-hand side is definitely more complicated on this one. Just because you see some double angles and some single angles, which is where I see there's a single X here and a double X here. That doesn't mean you can't do replacements for both. So I could look at both of them. First off, when I see that there's a double angle here and my answer is only a single X, I'm going to immediately take that sign of 2X out. So if I'm looking at my identity sheet, what does my identity sheet say I can replace sign of 2X with?
2 sine, cosine.
2 sine, cosine, right? Now, I don't see that 1 minus cosine squared anywhere in our answer. So I could also, in the same step, make a replacement for that. That does not have a 2X in it. So it's not one of our double angles, but I can still use the other identities. Does this one remind us of any of the identities that we've looked at so far?
The first Pythagorean identity.
The first Pythagorean one, it's a modified version of that, right?
Mhm.
That first Pythagorean one looks like this. If I moved the cosine squared to the other side, I could then make a replacement for 1 minus cosine squared with what?
Sine squared.
Sine squared. There you go. All right. So once we have that, I would then do a little bit of algebra here. Kind of looking at this, there's no number right there on top, but if there's nothing, it's an understood 1. So I'm getting closer to my answer because I see a 1/2 there. What else could I get rid of here?
Can you cancel out one of the signs?
Can cancel one of the signs. So what I'm left with right now is a 1/2 with 1 sine on top and 1 cosine on bottom, and we should be recognizing sine over cosine is the same as
10.
tangent. Good. So the double angle ones aren't any more scary than the other ones. It's just adding additional identities to use. I always like to talk about 11 because 11 is a good example of one where what looks more complicated isn't always the best option, but you could do it either way, honestly. Your gut on 11 would be to start where?
The right side.
The right side, probably. In this particular one, there's not a whole lot going on with it, but using what we've talked about over the last 2 classes, do we recognize that? Or could we find it somewhere?
Find what?
This that I've circled in orange, 1 minus 2 sine squared. Is that anything that we've seen before?
Oh, that's a cosine 2x.
That is one of my double angle identities. So even if it's not replacing a cosine of 2x with something, you can go backwards, which in this case kind of works for us. So because 1 minus 2 sine squared is equal to cosine of 2x, I can make that replacement. And now we haven't gone anywhere here with the double angles, which is part of the reason I like to go over this one. We know one of our identities that we talked about the first day is that 1 over cosine is the same as what?
Secant.
Secant. Now, just because there's a 2x in there doesn't actually change the fact that 1 over cosine is still the same as secant. It's just that when I say 1 over cosine is secant, I don't make it secant of x, I make it secant of whatever that is, which is 2x. So the double angle identities still work with the reciprocal ones. Secant of 2x is the same as 1 over cosine of 2x. Does that kind of make sense on that one? Honestly, let me see who's all here right now. More people than I expected. Well, maybe not more. Anyone, how are we feeling in general about proofs? This is like the worst part of being online for me. Like, I get a great feeling in class of like, oh my gosh, I have no idea what's going on. And then here it's just like, I don't know. I mean, no one's panicking, I don't feel like, but.
These are kind of nice, like they're not bad.
What's that?
They're like not bad, they're kind of nice.
I mean, here's the inner nerd in me usually comes out during class and all of this because I love proofs. They make me so happy. But sometimes I have people that absolutely hate them. So that is just life here that I have to get used to. But I feel like everyone's, despite the fun that this is staying home, we're all kind of doing okay as far as it goes. I don't know. The same people tune in with me, so I only am seeing about like 10 to 15 of you, and the rest are just like doing their work at midnight every day, which I'm like, whatever, have fun. But let me see if there's any other of these particular ones I want to go over to make sure that we can do more double angle stuff. 13 is interesting. Yeah, let's talk 13 actually. 13, this would be one where I would stick with the whole idea of start with the more complicated side, which in 13 would be which side?
Right.
Right-hand side. Now, 13 is a good one for me to talk about because I always have random people that are like, oh, look, it's so simple. Just divide the ones and divide the tangent squared, so you get 1. Please don't do that. Our algebra tells us that we can't split that one up because of the plus sign down here. Let's take a look at the right-hand side. One of these, and here's where we really have to know our Pythagoreans. One of those is a Pythagorean identity. Which one?
The bottom one.
The bottom one, right? So according to our Pythagoreans, I'm going to leave this one right now. What is 1 plus tangent squared the same as?
Secant squared.
Secant squared. Good. Now, here's my issue. If I'm looking at my answer right now, I'm trying to get to cosine of 2x. If you look at your cosine of 2x identities, what do all of them have to do with? Either cosine or
Sine.
sine. Currently, as we stand right now, I have no cosines or sines in my work here, which is not a great thing. So that tells me I should probably make some replacements here. One of our tools that we talked about last class was changing everything to in terms of sines and cosines. So using that kind of logic here, I'm going to leave the 1. What could I change tangent squared into that would put it in terms of sines and cosines?
Sine squared over cosine squared.
And using that same logic, what could I do with secant squared?
1 over cosine squared.
1 over cosine squared. Now, we do not love double fractions. So what does our algebra tell us to do with double fractions? Keep the top and do what with the bottom?
Cancel.
Flip and
Multiply.
multiply. So if I flip the bottom was 1 over cosine squared. I'm flipping it, making it cosine squared over 1 or just cosine squared. but the top has 2 parts to it. So that means I actually have to distribute. Cosine squared times 1 is cosine squared. Cosine squared times this fraction, what's going to happen?
The cosines are going to cancel out.
Cosines are going to cancel. Now, does this look somewhat familiar to us? It kind of looks like one of the Pythagoreans, except for the minus sign, right? But if I go through my list of identities, now going through all of them, including the double angles, what is that the same as?
Cosine 2x.
Which is our left-hand side. So we've made it there. Okay. Just to give you kind of an idea, because our quiz today, like I said, is just over the first 2 sets of our identities. It's our originals and like the reciprocals and the tangent and cotangent and all that. And then there are also the Pythagorean ones. But this is going to be a different like test. And the second quiz will be a little bit different too. We kind of split proofs into, instead of like sets of identities, proofs tend to be what we call easy, medium, or hard, if we're just categorizing them. Easy proofs are kind of what we started with on the first day, or typically any proof that takes like 1 to 2 steps. Like 11, I might have said, was kind of easy because you made 1 replacement for cosine 2x and then 1 reciprocal replacement, and that was it. Medium proofs tend to be something that includes more algebra. So factoring, foiling something out, in general, a proof that takes 4 to 6 steps, maybe. I don't know, just going with that. Things that will require you to get a common denominator. Things that just take more algebra. Those are medium level proofs. We have not actually hit hard proofs yet, which is kind of because you could kind of sense that with just not everyone's kind of feeling somewhat okay right now, which is good because some people lose it before the medium ones and just can't get it. So I'm feeling pretty good about this. Day 3 and like review day, we're going to move into the hard proofs and see where we can go with that. But your test, well, first, the quiz today I said is just basic stuff. So don't worry too much about that. I think like 90% of it is easy proofs. There might be like 1 medium-ish proof, but we've done some like it. The next quiz, the way I've set it up is to kind of guide you towards what the test is going to look like. The second quiz on proofs is like, I'll give you, here are 8 different things to prove, pick 5 of them. So you will kind of build your own grade. If you can't get one, try a different one. So that's kind of how proofs work a little bit more, is less you have to do everything and more just trying to do some of them. And so the test itself will be rather interesting. I've never done a test like this before this unit. But it will basically be, here's the easy section. There are about 10 questions listed in the easy section. You have to pick 7 of them to do. However, if you do additional proofs, like let's say you can do all the easy proofs, you can earn extra points on your test by doing extra easy proofs. So each extra easy proof that you do might be worth 1 extra point on your test. Medium, there might be 7 of them in that category and you have to do 5 of them. So there would be 2 additional medium proofs that if you could do those, you can earn an additional, let's say the medium proofs would be worth an additional 2 points each. And then the hard ones, I'm only going to make you do like 2 or 3 out of the 5, but those would be worth more points. I think I maybe did easy proofs are worth 2 extra points, medium are like 5. I can't remember. The hard proofs are worth a lot more. It might be like 1, 3, and 5 extra points or something. So you can kind of make up for any other mistakes that you've made somewhere else by doing extra proofs in another category. And there is like, when we get to the hard proofs for studying for your test, I'm going to be handing you like, here's these hard proofs, go do them. I will just say up front, like the people who don't review for this test, it's quite obvious because they didn't do what the extra stuff that I gave them to do. Because even on like online here, I've put up like extra things to do here and there. For example, today, let me see if I can pull up this part of my screen. Stop sharing that. Let's see. On Canvas for today, I actually made it an assignment. Let me pull my screen up for you here. I would like to show this, I believe. Nope. Apparently it doesn't like me. That. Okay. So on Canvas today, we are now under lesson 8.3. That is the thing I linked for today, so you don't need that. This proofs day 2 practice, I just wanted to show you all this while we're here. This is a good one to do in preparation or practice before the quiz. That's why I put it in the module before that. This is like, we used to do some of these in class, the around the room, where it had the answer somewhere around the room that you had to find, but I obviously can't do that because we're not there. So what you're gonna do in this is start in the first block here. You're gonna simplify this, and the answer to that is gonna be somewhere else on the page. Let's say it was this one, I don't know. Then you would simplify the next one, and you would find, and it would rotate around the page. If you get it right, you will end with the last question. This first answer would be it. So it's kind of a self-checking worksheet for you, since I'm not there to make sure everyone's doing okay. So that's a good practice in preparation for the quiz. I feel like this is mostly easy to medium stuff. Some of them are easier than others, but that's just kind of how it goes. Let's see. I would also like to do, let's go back to that double angles page real quick, and I'm going to do maybe 2 to 3 more, 2 more maybe, just to get some extra practice in it, and we will finish up with that. Oops, I have to go back to screen sharing that. All the buttons I have to press here. Let's find that. There we are. Okay, so let me see, what else is a good one to do? 17 is a good one to do, to check out, because it has a different way of looking at the double angles. Using kind of what we've talked about with proofs the whole way through, what side would you start with?
The right side?
I would say the right side, because it's obviously more complicated. What is the problem with starting with the right-hand side here, though? Do you have a double angle identity for cosecant of 2x? Or cotangent of 2x?
No, but couldn't you just take what you have and do the inverse of that?
Exactly. So even though we don't have an identity that says cosecant of 2x, I can change all cosecants to 1 over sines, but I'm going to keep the 2x in there. Cotangent, then I wouldn't want to do, I could do 1 over tangent. Those are kind of icky though, because the tangent is, the tangent's already a fraction. So rather than thinking about cotangent as 1 over tangent, I could think about it as what?
Cosine 2x over.
Mm-hmm. Exactly. Now, the other good thing about that being a cosine over sine there is, what do my 2 fractions already have?
Sine 2x.
They both have a common denominator. So before I ever do replacements, I can just go ahead and put them together. Now I would like to do some replacements here. The issue being for the cosine of 2x, and that's another reason I like to go over this one, is that you don't always know what to do. Sine of 2x, obvious. That has one choice. Okay, that's going to be 2 sine x cosine x. Cosine of 2x, I have some choices. Now, if you look at your cosine of 2x choices, there are good choices and there are bad choices based off of the problem, kind of the context of it. If you look at your answer, what are we aiming for here?
Tangent.
Tangent, right? So if I'm looking at the top part of this fraction, to me, I need to make a replacement for cosine of 2x that gets rid of that 1 out front. And that is because that's not in the answer, right? So that means for me, if I'm looking through, what are my three options for cosine of 2x? One is cosine squared minus sine squared. One is 1 minus 2 sine squared. And one is 2 cosine squared minus 1. Right? One of them I'm definitely not going to use. Any ideas? Which one should we not use?
2 cosine squared minus 1.
I would not use that one. Why would I not use that one?
You want sine on the top.
I do want sine on the top. Why are you thinking I want sine on the top? That's good reasoning.
Because the answer is tangent.
Because the answer is tangent, which is a sine over a cosine. That's great forward thinking there. The other one I would not use is this one, that top cosine squared minus sine squared, because nothing's going to cancel with that one. At least these two have a 1 in them that could maybe cancel out. So by process of elimination there, we're going to try this middle one. I don't know why I'm circling all of them. Okay, now we're going to be careful here. This is the place people screw up. When I'm replacing cosine of 2x there, I'm replacing that entire thing with 1 minus 2 sine squared. Notice I'm subtracting all of that. That matters in terms of the signs of our answer. Okay, that literally means I'm subtracting a minus or distributing a minus here. Okay, which is going to look like that. Now, what real good thing is going to happen for us right now? What's going to happen to my ones?
They subtract.
They
Cancel out.
cancel. Then what happens with my 2's?
They cancel as well.
Cancels. And then what happens with one of my sines?
It also cancels.
It also cancels. So we're left with sine over cosine. As you kind of get into this is a good place to talk about how much work you need to show. I would be fine with going directly from that step to tangent myself. Some people are going to make more leaps than others. But your homework kind of tells me already who's making those leaps and who's not. So I'm going to kind of be working with that to see like how many steps you typically show. It's always better to show more work than less. I'll just be honest on that one. Just to make sure that I can follow, because especially in the whole distance learning thing, as much as I'd love to trust everyone 100% all the time, what will be true is if someone's making leaps that don't make sense to me, it may be that they are getting that information from the internet or from someone else. Not that I'm going to immediately accuse someone of cheating, but just there may be a time that if I don't understand how you got from one step to the next, I might say, hey, explain this to me. And if there is like no explanation that you can give me, I can't really like help you out there. I got to try to be trusting, but also try to maintain integrity of everything that we're going through. Let's see, are there any other ones I want to talk about on this page? I don't actually think so.
So is all we're doing today is that sheet for 8.3?
Yeah, so there, as we go through proofs, we're not really adding as much. So really, let me stop sharing this. What we are doing then for today, that practice page before the quiz that I showed you and the quiz. And then the homework sheet for second period is not due till midnight on Monday because I'm going with like giving you an extra day to do it. You can, of course, turn it in over the weekend. I'm just not going to require it. For fifth and sixth period, they're not doing this information until Monday, technically. And then that stuff will be due Tuesday. Are the due dates working out okay for everyone? Enough time, but not too much, hopefully.
The practice sheet that we had to do before the quiz, do we need to submit that?
Yes, so it's the same as like a scan and submit thing. I just want to see how we're doing on it. And most of y'all, I'm not really worried about how much you're practicing. But there are some people that are not signing on that often. And by signing on, I don't even mean going live. Like I have people that just started 8.1 last night at midnight. So, you know.
The practice sheet that we're submitting, is that the proofs day 2 sheet that you're talking about?
Yes, yes. So that was under, where is that? Yes, it's called Proofs Day 2 Practice. That's the one that's submitted there.
That's for the quiz.
Yes, it says it's 3 pages. Don't print the third page. For some reason, the third page is blank. It's just 1 page front and back. So that's just kind of your practice to do. That's what I would have had you do in class before taking the quiz, and then we would have done that. So,
Are there any other sheets on Canvas that?
there's this sheet that I was just going through. I uploaded there for today. If you want more double angle practice, you don't need it before the quiz, but like just if you want more. And I uploaded the key, or if I didn't yet, I will be uploading the key to that. I'm making sure I get my keys to everything up there so that y'all aren't like panicky on that stuff. No, that's about it, I think. So do we need more? Are we feeling okay about what we have? Workload's manageable or no? First, yeah, mostly. Okay. If I can do anything more, I mean, I have not felt like that many people have been asking for extra tutoring and stuff. I'm around. I'm not going to sit there on Zoom waiting for people to jump on for a tutoring session. Unfortunately, with a 2 and a 4-year-old, like I'm paying a babysitter right now to take them out of my house to do this. So I will jump on if you need me. It may be with someone and their teddy bear, but you know what? It's okay. So let me know if you need help. I'm here. I'm able to help, and I can jump on. It's harder to like schedule it and sit there if no one's coming. So, but know that I am around to help for you. So yes, the practice page and the quiz, and that's it for today, and y'all are done. Okay? All right. I'm going to end this then, and we will be good.